Yeah, containers, and please let me know if you don't understand or if you want to argue or anything. It's intended to be fast. And what is a container? And that it's the buzzword, so it depends on who's talking about it. But one thing that's common is that we have something that has another file system than the host you're running on has. So a way of packaging, and it's not a virtual machine. And why do we have these? Well, it makes life easier. We can package software. We can have different versions installed at the same time, use them without problems, and we can avoid problems we had with virtual machines. We don't have to allocate resources that are not used. We can spin things up much faster. And we can also, if we make software, we can send that out and hope that it runs better than if we make something and it will be run with all different versions of everything, all the libraries. And so computers are quite new, but there's always history. So there have been VMs, and we have learned some things from them. They were used, and they are still used to run stuff, and it's a virtual or simulated machine. And we also have things like the containers we have today historically. And there have been things like that are more like containers and less like. And some were quite like the containers we have today, whereas cgroups were not so much. These things are typically done on Linux, and how it works, it uses a few things in the kernel. We have cgroups, which is used to control resources, control groups. Namespaces are used for separation, so you can make up a separate part and it won't see the rest of the machine. And there are capabilities, which is a way to control permissions more fine-grained than we used to. And we also have things for magic in the file system with bind mounts, so you can make something appear at different places. Union or overlay file systems that present a union of some things. And cgroups, these are available for, I think it's 7 or 8 kinds of resources. There are CPU. You can limit on memory, so you can say that something doesn't get more memory than you want it to. Or you can limit on local I/O and throttle, so you can't make things run slow for everything. Namespaces, we have these different kinds of them. Networks, so we can set up a completely separate network system that behaves differently from the rest of the host. Mount, that is used to get a new root place. Users, so we can run this root inside. PID, process IDs, always nice to have load numbers. We can have different time inside, and we can have different host names. Capabilities, yeah. And file system magic. We also have loopback, so we can mount things from a file rather than a physical device or a block device. And in essence, a container will just, it's a process, and we have added this magic sauce to make it special, but it's still just a process, and you can use everything you normally do to processes. You can kill it from the outside. You can run strace on it, and you can see what files it has opened. All those things you hopefully normally do, you can still do that, and it will behave as normal. And one nice thing about containers is that there's essentially they are as performant as they would be otherwise. If you have images on a network or a cluster file system, they can even be much more performant. But in general, you should expect the same as if you ran outside of a container. But there are a few gotchas. So if you have some libraries that are used in everything like libc, on your host, that will only be loaded once probably, or the same. It will be cached from a file cache, and that won't happen from a container because it's not the same thing. And also because of that, also memory merging and such things won't work if pages don't add up. And people try to do this thing on other OSes as well. And it's, if you're talking about Linux containers, you do that by running Linux because you need the kernel. So you have a VM, and if you run Windows and Windows services for Linux too, you run that inside the OS. So Microsoft takes care of it. So, and pretty much your options for this are Docker or using the Linux inside VSL2. And there are some things like Podman has a remote client, but yeah, it's not a native Windows thing, really. These things kind of work. There are a lot of issues, and particularly when people do stuff on macOS. Depending on how deep you go, you tend to run into problems. And I don't know much about these, but there are also Windows containers, and they run on Windows, and they contain Windows binaries, and that's essentially what I know. Yeah. Now, for when we run on Linux, there are different kinds of containers. So we have what I think of as persistent, where you essentially replace a VM with a container. And this might be, or is typically, an area in the file system or a special file system, but not normally an image. And for this, you normally use LXC or LXD. And when we have a thing people are most used to, which I think of as volatile, and that means that you have a container image that you run, but anything you want to work on or anything you want to change, you do that by mounting things into a container. You don't store that in the container, but you mount things into it. There are different tools for this, and normally we call them engines. And we have Docker, Singularity for HPC. Some people have heard of Podman, which is quite the same thing as Docker, really. And there are also a few more like ShardCloud, Shifter, uDocker, and Root. If you run on Linux normally or have your desktop on Linux, you also might have encountered snaps or Flatpaks or AppImage to deliver software. And those are just containers as well, actually. But yeah, you don't think of them as the same as container images like Docker, but there's no big technical difference. It's more of a support system. There's a containerd as well. And I consider most of these essentially done. They are not lacking a lot of things. There are some things that could be improved, but yeah. There are some things that Singularity doesn't have, like you don't have a kind of registries that you have with Docker Hub and so on, but it kind of doesn't need it either. And GPUs are still a problem. This is the case both inside containers and outside. And there is work on that, but yeah, it's still in flux. So some things aren't expected to work, basically. There's something called OCI, or Open Container Initiative, and it has, it standardizes things, basically, and it runs a few projects that are useful for various partners. I mentioned registries. It's basically places where you can store and fetch containers from. And these can be cloud-based, like Docker Hub, or it can be something you run yourself, like you run your Harbor. And some of these have extra services, like Docker Hub can build containers for you, and the company working on Singularity also has its own Singularity library, which also has some build functionality, and some are just storage. And the other tools I mentioned are mostly used in specific places. They are developed in some place and haven't really gained much traction. There are some people that use them, but not that many. And the main one that I guess the most people use is Docker. And it uses a layer approach. So an image, a container image, is made up of various layers that are then united to present the final file system. And this is useful because things can be shared between containers, and it makes things complex in a way when someone wants to know how large is this container, and it's not always clear what that means. And this layered approach is very visible in the build process. Docker is based on a common daemon, and so it's, if you look at the process tree if you run Docker, you will see that you have a Dockerd and things are dependent on that. If you kill it, then the subtree things will die, basically. It also means that the way it's done, it has the same user namespace for all containers. Yeah, how you usually use Docker, you'd run a root in the container, but you can have any user. But when you do these things, things behave differently on macOS and Linux, and that causes problems. You can bind mount stuff into Docker, and so you can have things in volumes, or you can bind mount directories or files. None of that is done by default. And you can normally change the file system, and it will be thrown away whenever the container dies. And we have to build a container. We have a Docker file that instructs Docker build how to do it. And we tell it from, so we base our image on something. So here we start with Debian, Buster Slim. And when we run some commands to do stuff, we upgrade and update, and when we create a file. And these are two different layers that will be added. And when we instruct Docker that when we run the container, we should say hello world. And we can also run it with different users. So if we run it normally, we will run as root. Whereas if we say that we want to use user 10, it will be started, the same command will be started, but with user 10 instead. And some things to know about Docker is that it uses the concept of a build context. So if you have a large directory that you have your doc sources in and so on, it will send all that to the Dockerd, and it can take quite a long time. And things may, depending on how it does caching, it might be happen things that you don't expect always. There's something called BuildKit, which is a new alternative way for Docker to build that you can select, and it has some benefits and some drawbacks. There are, as mentioned, volumes and bind mounts, and on Linux, those are really they are the same. You have a directory or a file that you mount into the container. But if you're on macOS, a volume will be run in the virtual machine, whereas a bind mount will be served from macOS to the virtual machine. And there's a performance bottleneck there, possibly. Similarly, if you have better FS, Docker might decide to create a subvolume for you and use that for the volume instead of having it in the normal file system. Singularity you will have heard of if you are using HPC, I guess. And it was built for a system that you are in a shared environment and you trust one another. So the tagline used to be, you're the same user inside the container as outside. And the default configuration is to try to be helpful. So you have a lot of stuff pre-mounted. That's home, and you have, also your sysadmin will likely, if you have like on Notmax, you will have project space mounted by default. And these are totally run separate. There's no interference between different runs. And images are stored as files, so they are easy to move or store or backup and so on. There's no overlay FS by default, so the image is mounted read-only and it's not changeable. You get an error if you try to change things. And it has been done so it can easily replace commands without being visible that you're using a container engine. And you can put stuff in to get the writable portion. And I think you shouldn't do that. There is a beta, I think it's called, for macOS It's not recommended for use. I think it's quite old if it hasn't received any log, but the recommendation I hear is to use Vagrant or something. Run a Linux machine yourself and run through that. And these also have some kind of recipes to build file or to build container images. And it looks quite the same. We can say that we want to use the bootstrap method library to pick something from a library. And we start with Debian 10. And there are other things we can do, but here we just do a post section. So when we set things up, we run this stuff in the container or the container build process. And we also inform Singularity that the run script, the thing to run when we ask Singularity to run the container is to run. Just say hello world and output the file in my ID. And we can build, and we can run, and we can run it as a command if we put it somewhere without calling explicitly on Singularity. And one thing that differs from Docker is that this is all done in one step. So the build process is done, and then it's all fed into a image creation process. And this means also that there is essentially no caching. So it can be time consuming to work with large build processes if you need to troubleshoot. Podman is to run containers, and Builder is to build them, and Scopio is to manage them and fetch and so on, essentially. And these are essentially tools Red Hat created because they didn't want to be dependent on Docker, but they are quite similar, I think, to what you can do with Docker. Builder lets you do things either with a Docker file, or you can have different steps that add a layer each, but that you can script with from your shell. There are a lot of different storage drivers. I don't even know what is there currently, and it's not very helpful, I think. I have also some of those are available when running as root and some are not, and things can be confusing at times. There is a build cache. It's not as effective as Docker. It's also much slower, or used to be the last time I tried it. And it can be run rootless. And you can use these containers in various ways. And one way you can use them is services, to run a service. And that's kind of a default use for Docker, at least in my world. Whereas in Singularity, you typically run a tool, but you can, of course, just have a one-off with Docker, and you can have a long running process with Singularity. And the detached mode for long running processes in Singularity, that's called instance. Yeah, there are some orchestration thingies. For development, Docker Compose is typically enough. And for larger orchestrations, Docker has something called Docker Swarm, and then there's, of course, Kubernetes. Security. Yeah, things are quite bad. Technology is quite good or available at least, but it's not used. And for people, there's not much attention paid to this, and I'm not sure what needs to happen for things to change. But I mean, if you use a container without verifying signature, you trust the registry you get it from, you trust the one who has constructed each layer. So there's a lot of people that you trust there. And it can also happen that some, like, I think HashiCorp was in the code of the attack. So even if they are trustworthy by default, they can make mistakes or things can happen because they trust someone else. So there can be a lot of fallout from things. Yeah, Rootless. Base use case for Singularity. In the plan when Podman was done and supported by Docker, all of these need something special, typically. So Singularity, you can install it yourself and run, but you really don't want, you do want setuid install. So you need support from a sysadmin. Podman, similarly, there are some Podman by itself you can install, but for it to function properly, there are some things needed that need to be installed. And similarly for Docker. And there's a few that are like uDocker or enroot that are special cases, and those also depend on various environments. And the technical detail for this is that you basically always want user namespaces, and then you want the tools for that called new gidmap. And there are some things that differ as you can't count on. So on Ubuntu, overlay.fs allows some things as user that requires root in upstream. So it's not very easy to build an engine over time. You will need your sysadmin people to set up user namespaces and create the user map, basically. There are other tools like Fuse being required for some of these, but most, it's not much work at least, but you need the user namespaces set up. So having etc subuid and subgid files. And there's always a business side of things. If the people doing this can continue to be paid, or what can happen. And my view is that there probably will be a Docker for quite some time. I have no doubt someone will be working on these things. Because you can probably get money from someone to do it. Docker is now owned by Mirantis, or at least the enterprise part, and Engine was part of that, as far as I know. And they seem to just throw stuff at the wall, so it might be delayed sometime, or I mean, things might happen, but long term, I think it will survive. Singularity, there's a company called Scilabs that pay people to develop. I'm not sure if they have any paying clients or how many and so on. There's a organization set up to handle it otherwise, but I don't know how much manpower they can get to work on it. But then again, it's mostly done, so it's you want someone familiar with the code base to handle security details when they pop up. But most of it is quite done. And so what I think are good practices, you probably want to develop with Docker because it will be fastest. Yeah, it will be nice, and it's a thing that almost everybody can run. You can tell them how to easily, and you will need to try with Singularity probably, and you should run with specific users, so not run everything as root. You also probably want to try that you can throw stuff from outside at it. So like mount home directory and see that you don't break because you bring in the .r directory from your user. But basically also the runtime or the engine shouldn't matter. If you need to run with Docker, there's something wrong. If it doesn't work with Podman or so on. I hear that. Yeah. Test with a non-root user. And if you run macOS, there will be problems and you should be prepared for them. And after a while, you get to know them. Yeah, I think that's what I intended to say.
Thanks very much, Pontus. Does anyone have any questions for Pontus? You can unmute yourselves and ask your question yourself. So yes, Winnie, you raised your hand. Yeah. Can't really hear you. Sorry.
How about now?
Yes, that works.
Yeah.
Okay, that's my fault. Thanks for going through all this, Pontus. And I've had some experience using Docker and Singularity over the past few years, but I guess my question is, it sounds like if you are sort of a casual user of Singularity or Docker or containers in general, and you're just trying to do some computational biology, there seems to be a lot of overhead to get these things to work right. I was just wondering what your sense of that is, or maybe also for other people on the call. Like, is it really worth doing this if you're running sort of a more computational biology pipeline and you just want to do some reproducible research, or is Conda for tracking your dependencies sufficient in practice?
Yeah, I was not sure if I should go into that, but yeah, you should use this instead of Conda. Conda makes everybody cry. So, or at least there are ways you run into various sorts of problems, and it will be a lot less efficient if you, or at least it can be in some situations, or if you run on a cluster with a network file system. So I definitely prefer using containers than Conda. And then, I mean, most of these are pre-built. So if there is a tool that is built by Conda, I think it's available as both Docker and Singularity containers already. I should have checked that, but I think the biocontainers have automatic builds from Bioconda. But in general, yes, it's definitely it's more of a daring to try. It's not difficult. It's more that psychological threshold that it seems scary, but you might have been using containers without knowing. Like, say, if you run Slack on Linux, you might be using a container, or some tools on Upmax are installed as containers, and you don't see that. But yes, I'd recommend trying to move away from Conda. Conda is great for having one, I mean, you can make a container from Conda. That works great, but trying to keep Conda and having it survive over long times, or it's not always great. I find it at least much easier to work with containers for tools such as that.
All right, there's also a question in the chat from Volmar, and he asks whether you have any recommendations on what to consider when reusing existing images, example from Docker Hub.
Yeah, common sense, which to me, I mean, there are a lot of recent attacks where people try to basically upload containers that are using common names, or so they base it on a common image, and when you have that, but you also have a CryptoCoin miner installed that's running, and so typically, if it's the official vendor, that's good. Otherwise, if it doesn't have a few million pulls, that probably means it's not what you want. If it has like 10,000 or 400 or so, it may be that you want to look at a Docker file and copy that rather than basing it on that container. So being careful and trying to be suspicious.